Hello everybody. Today I'm going to talking about frequency and phasing of this simplified Ruslan circuit. I have explained why this capacitor is unnecessary in my last video, and now I'm going to test without this capacitor. In the same time, I have all other circuit exactly the same with Ruslan's original circuit. This wire you see right now is from the grenade. It connects directly into the transformer. This is the ground wire of the grenade coil. It connects directly into the ground pin and also the Tesla grounding wire. This 3 turns coil in the middle goes to the inductor and its capacitor. I'm using the exact same capacitance that I was using in my last video. I have this probe as a reference wave that you can see the phase difference afterwards. This current probe can give you a clear vision of the phase difference. I will tune it into the peak of the resonance. The peak is at 30 kilohertz. It's reasonable that the mutual inductance will raise up the resonance frequency, but it's still shocking to me that it's just right at 30 kilohertz. It's the 2 times of 15 kilohertz where I calculated my resonance capacitors. I don't understand why this is so accurate. If you know, please leave your mathematics in the comment below. Right now we consume 1.4 amps. This test pen has a range from 100 volt to 500 volt, and there's a neon inside it. This primary capacitor is really hot. It shocked me many times when I touch it with my bare hand, so I have to wearing a glove. Actually, entire of this loop is very hot, from the coil on the transformer until the bifilar or inductor winded on the grenade and the triangle section. They're all really hot. A LED bulb is easily light up here. It means that it's more than 200 volt peak to peak. And I'm shorting here. There's pretty much a spark here. I used this 5-watt bulb to make a test right now. It's light up, even the light is too dim. But yes, it could light up. I didn't put full power, only 12 volt right now. This 10-watt bulb also light up very dim. Very dim to me, because they should be very bright at 220 volt. This one is a 20-watt bulb at 220 volt. I still have the PTSD here after the shock. All these 3 bulbs give the same light. They're all pretty dim. They look pretty much the same. There's another part of the test. I have to insert it here. It's not in the main video. Here I have a gas discharge tube that is used in Don Smith's something circuit. It's 75 volt voltage limited, and you can see here that it's light up even going through the gloves, so the voltage is really high here. I can't really test it with my probe, but the secondary grenade side, it has no voltage at all. It doesn't light up at all. Means that it's lower than 75 volt. Here you can see the difference. One is lighting up very bright, one is barely light up. Now I'm sure that I'm safe. I'm safe with gloves. It's safe to touch this way. Now let's back to the main video. I will give a mark on my scope of this blue trace. This blue trace is the current trace from the current probe. Right now it should supposed to be in grenade side. You can see the frequency is still 30 kilohertz. When I open this magnetic loop, you can see that the wave is changing. So you know that this is really from the probe. My inductor and my grenade, they are all wind in the same direction. You can see that from the first layer of the winding, the wire bent to right side. Yeah. And the top layer is bent to the left side. So in my test, I will test these 2 black wire. These are all the initial wire from the winding. I have marked the peak of the grenade current wave right now, as you can see. And now I will switch into the inductor primary. As you can see, the wave is opposite. It's a 180-degree out of phase. Now I switch into the end terminal of the primary inductor. As you can see, the wave become opposite again. And the peak is just right at my mark. So all of these tests means that we have opposite magnetic field exist between inductor and grenade coil. Double checking the result, and they are really 180-degree phase shift of the current and magnetic field. And I put this device running for a while, for about 10 minutes, and then I'll test about the temperature of the grenade, temperature rising of the grenade. Here I have a infrared thermometer that right now I have my room temperature at 22 degrees Celsius. And the top of the grenade is 32 degrees Celsius. And the middle of the grenade is 31 degrees Celsius. And inside the biffilar or inductor is 22 to 27 degrees Celsius. They all rise up a little bit from the room temperature. The grenade is hotter because it has smaller inductance, and smaller inductance, higher capacitance make higher current of resonance. In the future, I will try this 123 frequency lock that Kurt had shared me this information. I'm working with Kurt Cocaine on this project, and I sent this PCB board I made myself so that we can make experiment that is repeatable, more scientifically ensured. He had an extraordinary effect with my board. He told me basically 3 point. He had 1.2 wire lengths between grenade coil and inductor, and he had 1 to 3 frequency lock, and he had 1 to 16 ground wire. To me, the grenade and inductor 1 to 2 wire lengths is not that special to me because I think this frequency influence is already inside this 760 kilohertz grenade half-wave resonance frequency. So I will focus on 1 to 3 frequency lock and 1 to 16 ground wire. And this 1 to 16 ground effect is also mentioned by Don Smith. He used a variable capacitor or variable resistor to replace the long wire. I will maybe try in that way. Thanks for your time. If you find anything interesting, please like and subscribe.